Have you ever thought about this? Right now, as you watch this video, entire galaxies are silently disappearing from our universe. Not exploding, not dying, just crossing a line in space. A line after which their light will never reach us again. We will never see them, never study them. It's as if the universe is slowly closing its curtains. But where is this line? Does the universe actually have an edge? And what was there before everything began? Today, we're going to the very limits of space and time to find out. Space, the final frontier. From the tiniest particles to the largest galaxy clusters, the universe is full of mysteries that don't just confuse us, they redefine what we think reality is. In this video, we'll explore the true edge of the observable universe. White galaxies are vanishing forever. How the universe might end. And some crazy theories about what came before the Big Bang. If that sounds like your kind of journey, make sure to like, subscribe, and hit the bell. Because after this video, you'll never look at the night sky the same way again. Let's start with something simple. Everything you have ever seen, your room, the moon, the sun, distant galaxies, all of it is inside one giant bubble. We call it the observable universe. It's not the whole universe, it's just the part from which light has had time to reach us since the beginning of time. Right now, that bubble has a radius of about 46.5 billion light years. But here's the weird part. The universe is only about 13.8 billion years old. So how can we see 46.5 billion light years away in only 13.8 billion years? The answer is the universe itself has been stretching. Space isn't a static stage. It's more like a rubber sheet that's constantly being pulled. While light from distant galaxies was traveling towards us, the space in between was expanding, dragging those galaxies farther away. So when we see something 13.4 billion light years away, we're actually seeing ancient light that started its journey long ago. The place it came from is now far, far beyond that distance. Our bubble is not showing us where things are, it's showing us where they were. To understand the edge of what we can see, scientists talk about cosmic horizons. Think of yourself at the center of a sphere. 1. Particle horizon. This is the maximum distance from which light has had time to reach us since the Big Bang. It defines the size of our observable universe. 2. Event horizon. This one is more brutal. It's the distance beyond which anything that sends a signal today will never reach us. Not in a trillion years, not in an infinite future. 3. Hubble horizon. Beyond a certain distance, space is expanding so fast that galaxies there are receding from us faster than light. Not because they're breaking physics, but because space between us is stretching faster than light can cross it. So when we talk about the edge of the universe, we're not really asking where the universe ends. We're asking how far can information actually reach us? And those horizons are getting worse. Every time you look up at the night sky, you're not seeing the universe now, you're seeing history. Light from the sun takes about 8 minutes to reach Earth. Light from Proxima Centauri takes 4.2 years. Light from very distant galaxies is billions of years old. So when we detect light from a galaxy that's 13.4 billion light years away, we're looking almost all the way back to the beginning of time. That's how we discovered the greatest clue about the origin of the universe. In the 1960s, two astronomers, Arno Penzias and Robert Wilson, were working with the radio antenna. They kept picking up a strange hiss. No matter where they pointed, the noise was there. They cleaned the antenna. They blamed pigeons. Nothing changed.
Eventually, they realized this wasn't noise. It was the echo of the Big Bang. We call it the cosmic microwave background, the oldest light we can see left over from when the universe was only about 380,000 years old. Back then, the universe was a hot, dense plasma. Electrons and protons couldn't form atoms. Light kept bouncing around. It couldn't travel freely. Then the universe cooled down enough for atoms to form. The fog cleared. Light was finally free to move. That very first light is still traveling today, stretched out into microwaves as space expands. By mapping tiny temperature differences in this globe, scientists discovered something shocking. Most of the universe is invisible. The cosmic microwave background told us that only about 5% of the universe is normal matter. About 26-27% is dark matter. Around 68% is dark energy. Dark matter doesn't emit light, but its gravity shapes galaxies and the cosmic web. Dark energy is even stranger. It's a mysterious force that's causing the expansion of the universe to accelerate. And that acceleration is what will eventually trap us in a tiny island of space, cut off from the rest of the cosmos. Let's fast forward. 1 to 2 billion years from now, the sun slowly gets brighter, a little bit every 100 million years. At some point, temperatures rise too high. Oceans start to evaporate. Photosynthesis fails. Oxygen levels drop. Earth becomes less like a blue paradise and more like a drying, overheating rock. About 7.5 billion years, the sun swells into a red giant. It grows so large that it likely engulfs Mercury and Venus, and quite possibly Earth. Our planet is incinerated. The rocks, the oceans, every trace of human civilization reduced to hot plasma and scattered atoms. After that, the sun shrinks into a white dwarf, a dense, Earth-sized ember slowly fading in the dark. By around 100 trillion years in the future, no new stars are forming. Existing stars have burnt out. The universe is lit only by fading embers, white dwarfs, neutron stars, and black dwarfs. This is the degenerate era. Galaxies are graveyards of dead stars. Gravity keeps working behind the scenes. Stars and remnants fall into black holes. Others are flung out into the cold void. Over even longer timescales, even white dwarfs cool and become invisible black dwarfs. The age of black holes. Eventually, black holes become the main large objects left in the universe, but even they are not eternal. Thanks to a process called Hawking radiation, black holes slowly lose mass over unimaginable time spans. They evaporate. One by one, the last black holes disappear in faint flashes of energy. What's left? A dark, almost empty universe. Thin radiation, sparse particles, no structure, no stars, no life. This is one of the leading endings, the heat death of the universe. Not with a bang, but with a long, slow fade into darkness. Other possible endings, Big Rip and Big Crunch, quick. There are other scenarios too. Big Rip. If dark energy becomes stronger over time, the expansion might accelerate so violently that galaxies are torn apart. Solar systems are ripped open. Even atoms are shredded. Space itself rips everything apart. Or Big Crunch, Big Bounce. If gravity eventually overpowers dark energy, the universe could slow, stop, and reverse. Galaxies fall back together. The universe contracts, and everything collapses into an ultra-dense state. And that brings us to the biggest question of all. We know the universe as we see it started about 13.8 billion years ago from a hot, dense state we call the Big Bang. But what happened before that? Did time even exist? Here are some of the main ideas. The oscillating universe, a cosmic breath. One idea imagines a universe that cycles forever. It expands, slows down, contracts into a big crunch, and then somehow rebounds into a new Big Bang. In this picture, our universe is just one phase in an endless cosmic heartbeat. Before our Big Bang, there was a previous universe collapsing. The problem is, today we see accelerating expansion, which doesn't point toward a future collapse. at least with our current understanding. Multiverse, our universe as one bubble. Another idea is the multiverse. Imagine an infinite ocean of space where bubble universes constantly appear and expand. Each bubble has its own laws of physics, its own Big Bang, its own beginning and end. Our universe would just be one bubble. Some versions even suggest collisions between these bubbles could trigger events like our Big Bang, or our universe formed as a quantum fluctuation in a larger multiverse. It's a fascinating idea, but very hard to test. No boundary. No before. Stephen Hawking and James Hartle proposed something even more radical. According to their no boundary proposal, space and time are finite but have no sharp edge. The Big Bang isn't a point where physics breaks, it's more like the North Pole of time. Asking what happened before the Big Bang might be like asking what's north of the North Pole. In this view, there is no before. Time itself begins with the universe. Big bounce and quantum gravity. Another approach comes from attempts to combine quantum mechanics and gravity. In big bounce models and loop quantum cosmology, the universe doesn't collapse into a true singularity. Instead, at extremely high densities, quantum effects create a kind of bounce. A previous contracting universe rebounds and starts expanding. That's our Big Bang. If that's true, then before our universe, there might have been another universe connected through a quantum bridge. So, what was before the Big Bang? Right now, we don't know for sure. Maybe our universe is one of many. Maybe it's part of an endless cycle. Maybe it was born from another universe's black hole. Or maybe the question, before, doesn't even make sense at the deepest levels of reality. But here's the amazing part. You were alive at a time when humanity can seriously ask these questions and even begin to test some of these ideas. So let me ask you, which theory blows your mind the most? The heat death, the big rip, the multiverse, or the big bounce? Tell me in the comments. If you enjoyed this journey to the edge of everything, don't forget to like, subscribe, and hit the bell so you don't miss the next trip through space and time. The universe might have horizons, but our curiosity doesn't.